A very good morning to all of you. This is your mathematics class, and today we are going to continue the chapter sets, which is chapter 19 from your book. As you know, before the exams, your PA2, before your PA2, we have done two exercises of this chapter, that is 19.1 and 19.2. And today we will do exercise 19.3. But before starting the exercise, let us discuss about some basic concept of this exercise. See, the name of the topic is operations on sets. So what do you mean by operations of sets? See, there are some operations which can be usable for two or more sets. That means several operations that we can apply for two or more sets. So let us discuss about some operations here. Okay, the first one is union of sets. The first one is union of sets. So what do you mean by union? Union means, the term union means a together, okay, that means a collection, you can say a collection. So what do you mean by union of sets? So the union of sets, just like you have set A and set B, these are two sets which you have, and you have to find out A union B. So what do you, first of all, there is a sign for the union which is like U. So A union B, we can denote A union B as in this way. So A union B can be defined as the set that contains all the elements, all those elements which are present in A, which are either, not which are present in A, which are either in A or B or both. That means we can say we have some elements in the set A and in the set B. So if we want to find out A union B, then it contains all those elements which are in either A or in B or both. So let us do a question based on that concept, by which you will clearly understand the concept. Here you can see your exercise 19.3, question number 1. In the question number 1, you have set A which is 1, 2, 3, 4, 5, and set B which have elements 1, 3, 5, 7, 9, and set C which have elements 2, 4, 8, 10, and you have to find A union B. So as you can see that these are the elements of set A and these are the elements of set B, and you have to find A union B. So how you can find it? First of all, A union B, that means for A union B you have to pick up the elements which are common in both, just like 1 is common in both. So A union B is equal to sign of set, then 1 is common here, so you will write it once. After that 3 is common here, so you can write 3 once, and 5 is also common in both the sets, so you have to write 5 once. Now in the set A you are left with 2 and 4, and in the set B you are left with 7 and 9, so you will write these elements also, 2, 4, 7, 9. Now you can arrange them in a sequence. That just a second. That means you can write it in the way set 1, 2, 3, 4, 5, 7 and 9. So this is the A union B. First of all you will write the common elements, after that you will write the remaining elements. In a similar way you can find out B union C. B union C, B union C. As you can see that is there an element which is common for both? 2 is present in C but not present in B. 4 is present in C but not present in B. Similarly 8 and 10 are present. 8 and 10 are present in set C but not present in B. So you will write all the elements which are contained by set B and set C. That means you have to write 1, 3, 5, 7, 9. These are the elements of set B, and after that set elements of set C, that means 2, 4, 8 and 10. This is the A union B. I hope you understand the concept of union. Now you can write 1, 2, 3, 4, 5, 7, 8, 9 and 10. This is the A union B. I hope you understand it. If you have any problem regarding this concept, then you can ask. Now we will move towards the next concept. This will be the intersection. Just like intersection is just opposite to union. Okay, we denote union by U and we denote intersection by opposite U. Let us see, just a second. Here it is A intersection B. Intersection of sets. So what do you mean by intersection? See, if we want to find, if we have two elements, element A and element B, and we have to find A intersection B, then A, this is the sign of intersection. This is the sign of intersection, just opposite of U but downside. A intersection B, this will be called A intersection B. So this is the sign of intersection, and we can define A intersection B as the set that contains all those elements which are both in A and B. That means we can say the elements which are common in both the sets, that will be the intersection of that set. That means we have to find common elements from both the sets. Then we can write intersection of these two sets. Just like we have set A 4, 5, 6, set B 5, 8, 11 and set C 5, 8, 12, and we have to find A intersection B. So how we can find A intersection B? This is the set A and this is the set B. We have to find the elements which are common. 4 is present in set A but not present in set B. 5 is present in set A and also present in set B. So we can write 5. Now 6 is present in set A but not present in set B. Similarly 8 and 11 are present in set B but not present in set A. So only 5 is the common element from both the sets. So A intersection B will be 5. Similarly you can find for B intersection C. Now B intersection C. B intersection C. So again you have to see the common elements. 5 is present in set B as well as present in set C. So 5, we will put 5 here. 8 is present in set B, also it is present in set C. So 8 is also the common element in the set B and C. 11 is present in B but not present in C. So only 5 and 8. Only 5 and 8 are the common elements from set B and set C. So B intersection C will be 5, 8. 5 and 8. This is the intersection. Hope you understand the concept of intersection also. Now we will study about the properties of union sets. There are some properties of union sets. So the first one is A union B is equal to B union A. That means if we find A union B, then it will always equal to B union A. You can prove that, means you can apply any of the sets, and you will find that left hand side and right hand side both are equal. Now A union A is always equal to A. See, set A is same, so also union will be the same. So A union A will be A. Now A union phi, this is called phi. Remember I told you this is called phi, and this means this is the null set. That means it have no element. So when a set you have 1, 2 and 3, and the set B you have only you have no element. Okay, that means it is phi. So the A union B will be equal to 1, 2 and 3 also, because set B is not containing any element. Now A union U is the universal set here. I told you about the universal set in the previous exercise. Universal which contain everything, means all the number of elements contained by the universal set. So if in set A you have 1, 2, 3, and in U you have 1, 2, 3, 4, 5, 6, 7, 8, just like. So A union universal set will be equal to universal set, is always equal to universal set. Similarly, if A is the subset of B, then A union B is equal to B, because all the elements of set B, if you have the condition A is the subset of B, that means all the elements of set B are present in the set, all the elements of set A are present in the set B. That's why A union B is equal to B. Hope you understand this also. Now let us move towards the next topic, which is disjoint set. So what do you mean by disjoint sets? See, again suppose you have two sets, set A and set B, and you want to find out the disjoint set. So it is just opposite of intersection. That means always you will find the common elements, but in disjoint set there is no common element. There will be no common element in the set. So you can say, if set A and set B do not have any common element on their intersection, then it will be the disjoint set. Suppose set A you have 1, 2, 3, and set B you have 4, 5, 6. As you can see, no element is common here. So A intersection B is equal to 5, because if no element is common here, then the element in the common will be 0, and you can write the null set as 5. So A intersection will be equal to 5. That means there is no common element in the set A and set B. And this way, if this is equal to 5, that means if A intersection B is equal to 5, then it means it is disjoint set. It is disjoint sets. See the question based on this disjoint set. See the question number 4. Just a second. See the question number 4. Which of the following sets are disjoint sets? That means which have no common element. This will be the disjoint set. So see, A, E, I, O, U. This have A, E, I, O, U. Suppose this is the set A and this is the set B, and you have to find A intersection B. Now you can see that A is present in set A but not present in set B. E is present in set A, also is present in set B. So you can see E is the element which is in A intersection B. So it have the one element is common. So this will not be the disjoint set. Now see, suppose this is set A and this is set B. Now 2 is present in set A, but not present in set B. Similarly, all the elements are the elements that are present in set A are not present in set B. That means you can say there is no common element in set A and set B. So A intersection will be equal to 5, and if A intersection B is equal to 5, then it is the disjoint set. Similarly, even natural number and set B have, suppose it is set A and it is set B. Set A have even natural number and set B odd natural number. See, if the numbers are even, that it is not possible that it will be odd, because even natural numbers and odd natural numbers are different. That means again in this part A intersection will be equal to 5, and if A intersection B is equal to 5, then it is disjoint set. Also see the question number 3. X is a natural number, set B even natural number, set C odd natural number, and set D prime numbers. See, suppose you have to find A intersection B, all the natural numbers and all the even natural numbers. So when you subtract when you subtract even natural numbers, if you see the common elements in set A and B, then it is natural numbers, but they are even and they are all, that means combination of even and odd. So you have to try this question by yourself. Okay, similarly these have even natural number, odd natural number. You know odd natural numbers are 1, 3, 5, 7, 9, all these, and prime numbers 2, 3, 5, 7, 11, these are prime numbers, and so on. So on the basis of these facts you have to try the question number 3. Now let us move towards the next topic, which is difference of sets. As you can understand from the term difference, that means it is talking about the subtraction. This is talking about the subtraction. Suppose you have set A and set B, and you have to find the difference of these two sets. So that means A minus B. You have to find A minus B. So A minus B will be the set that contains all those elements which are present in A but not present in B. Means you can say that all elements of A except the common elements of A and B. Let us do the question based on that concept, by which you will understand easily this concept. See, you can find A union B, B intersection C, A intersection C. I told you about the concept of complement. This is the sign of complement. This time we are talking about the difference, A minus C. As you can see, the set A, these are the sets which are given. In the question number 5, this is the universal set, means which is containing everything, and set A have these, set B have these, and set C have these. You will see that elements that are present in set A, set B, and set C, all the elements of these sets are present in set U, because this is the universal set. This time you have to find out A minus C. A is 10, 12, 15, 16, 19, and C have 10, 14, 15, 16, 20, and you have to find A minus C. So first of all you have to see which are the common elements. 10 is present in set A and set C also, so this is the common element, so you will not write 10 in the set of A minus C. Next, you have to find A minus C now, so you have to see set A, elements of set A. 12 is present in set A but not present in set B, so 12 is the element of this set. The next is 15 in set A, also present in set B, so we will not write it because this is the common element. We know that if we have we know that if we have 2 minus 2, then it will be equal to 0. So if we subtract 15 from 15, this will be 0. 16 is present in set A, also present in set C, so we will not write this also. 19 is present in set A but not present in set C. That means 19 is also the element of set A minus C. See, if you are subtracting C from A, that means A minus C, then you will subtract the element of C from the set A. From the set A, that means you will write the element except the common element from set A. But if you have C minus A, then you will see the elements of set C. That means you have to write the elements of set C except the common elements in the set C minus A. Hope you understand this also. Now let us move towards the next topic, which is properties of difference of sets. So A minus B does not equal to B minus A. The result of A minus B and the result of B minus A will be the different. B, A minus A is equal to 5. Obviously, if we subtract 2 minus 2, then it will be 0. So, A minus A is equal to 0 set, that means 5. A minus 5, obviously, if we subtract 2 minus 0, that will be equal to 2. So, if we subtract null set from set A, it will be equal to A. A minus universal set is equal to 5, because if we subtract everything from something, then it will be nothing. Okay, but if we have U minus A, then it will be equal to U minus A, then it will be equal to A dash. This is the concept of dash. Okay, and this is called complement of the sets. This is the complement of the sets. If we want to find out the complement of any set, then we have to subtract that set from the universal set. Okay, so the complement of set A is denoted by as A dash. This means complement of set A and is defined as the set of all elements present in the universal set U but not present in A. That means U minus A is equal to A dash. If we subtract the elements of set A from the universal set, then it will be equal to the complement of that set. Here are some properties of complement sets. A union A dash is equal to always universal set. A intersection A dash is always equal to phi. A complement of complement is equal to always equal to the same set A. Set of complement of universal set is always equal to phi, because universal set is the largest set which contains everything, and phi dash is equal to universal set. Okay, because the opposite of nothing is everything. A union B complement, then that means firstly you will find A union B. After that you will subtract the result of A union B from U. Then you will find A union B complement, and it will always equal to A complement intersection. See, here is the sign of union, but here is the sign of intersection. A complement intersection B complement. Similarly, A intersection B complement is equal to A complement union B complement. See some questions based on this topic by which you will easily understand the topic. Okay. See the question number 7. Here you have to find A complement, and this is the set A, this is the set U. If you want to find out A complement, then you have to subtract A set from the U set, universal set. Now you can see one is present in set U and also present in set 1. That means we separate the common elements 1, 2, 3, 4. These are the common elements in both the sets. Now you are left with 5, 6, 7, 8, 9. That means universal set minus set A is equal to 5, 6, 7, 8, 9, and this will be the A complement. 5, 6, 7, 8, 9. Similarly, if you want to find out A intersection C, then first of all you have to find A intersection C. That means common elements in set A and set C, and that will be equal to 2 and 4. Only 2 and 4. Now you have to subtract this A intersection B from the A intersection C from universal set. Common elements are 2 and 4. That means A intersection, just a second. That means A intersection C complement is equal to universal set minus A intersection C set. So U minus universal set minus A intersection C set will be equal to 2 and 4 are the common elements, so we will remove them. Now that means you are left with 1, 3, 5, 6, 7, 8 and 9. So this will be the answer for A intersection C complement. Now if you want to find out A complement, then first of all you have to subtract, it will be the result that A complement is always equal to set A. But if you do U minus A, then you will find A complement. Then again if you subtract A complement from this universal set, then you will find the set A same. Similarly, you can do question number 8. Here set A given, set B is given, set C is given, and also the union set is given, and you have to find A union B, A intersection B union C. For this, firstly, for the part B, firstly you have to find B union C. After that, the result of B union C, you have to subtract that result. You have to see the common elements from B union C and A. Similarly, you can find A complement intersection B minus C. First of all, you have to find A complement, that is U minus set A, universal set minus set A. After that, you have to find B minus C, and then you have to find the common elements in the set A complement and set B minus C. All these questions have to be done, and you have to do all these questions in your notebook. If still you have any problem, then you can ask.